All right, so mass. So again, like I said, the most valuable part of chemistry, and the part of chemistry, or stoichiometry, the most valuable part of stoichiometry, and the most used is mass. So in a week or two, when I give you 10 grams of sulfur, you're going to need to calculate how many grams of potassium nitrate you should use. Okay, so gram, mass. So we're going to do a few of them together. And we got our favorite reactions up here, the creation of water with hydrogen and oxygen, and then the reaction of hydrochloric acid and zinc. So here's our first one. We'll go through together. How many grams of O2 with as much hydrogen as we want are required to produce 16 grams of water? So how much oxygen in grams, how many grams of oxygen are we going to make if we have as much hydrogen as we want and 16 grams of water? So to start that out, what is my given unit?
16 grams of water.
Yeah. 16 grams of H2O? H2O, okay. Now if we go, nothing goes in this box. All right, so far so good? Reading the exercise, 16 grams of water. What's my next step?
Put in the H2, or the O2.
Grams H2O down.
Bring the grams H2O down. I'm going to bring down the grams of H2O, and to what, I'm sorry, wait till you're done. Okay. To what am I going to convert? Moles H2O. Why can I not just go grams H2O to grams O2? Yeah, because there is no conversion. There is no conversion between grams of one thing and grams of something else. It does not exist. You can't do it. Don't even try. Okay? So you got to go from grams to moles, then we can use our mole ratio, and then we can get to our grams. So grams H2O to moles H2O. In a gram to mole is always what number? 1. Mole is always 1. And grams in this case is 18. Found that off the table. So 1 plus 1 plus 16 off the table. Okay. Give me a thumbs up if you're comfortable with this so far. Okay, looks like most of you are good to go. Some of you are still working on picking your nose. Okay, so that's gross. What's next?
Moles of O2. Or moles of H2O.
Moles of H2O comes down. So I'm going to move down my moles of H2O. And to what am I going to convert?
Moles of O2.
Moles O2. See, now we can use a mole ratio to change our chemical. This is the only time we can use a mole ratio to change our chemical, once we have our first thing in moles. Okay. And where does this mole ratio come from?
From there. 16 divided by 18.
Nope. From
2 to 0. Or 2 to 1.
the balanced chemical equation. The mole to mole ratio comes from the balanced chemical equation. The full mole ratio for our reaction is 2 moles of hydrogen, 1 mole of oxygen, 2 moles of water. Okay. The mole ratio, the mole ratio comes from the balanced chemical equation. So what number should I put up here for oxygen?
1.
Oh, 1. And what number should I put down here for water? 2. All right, cool. We're almost done.
Now you bring your moles of O2 down.
Bring down my moles of O2. Okay, you're the boss. Moles O2. And to what am I going to convert?
Grams of O2.
Grams of O2, which just turns out to be my goal unit. Yay! So I got a gram to mole. Where do I find a gram to mole conversion?
Molar mass.
Molar mass. Good. So 1 mole of O2 has a weight of how much?
16.
32.
32.
Each oxygen is 16, so we got 2 of them, so it's 32. Now, we have our goal unit. Yay. Now we can do our math. Please be careful with your order of operations. Your math is going to be 16 by 32 divided by 18 by 2. Two ways to go about this. You can go 16, pretend that's a 16. You can say 16 times 32 divided by 18 divided by 2, or 16 by 32 divided by 18 times 2 in parentheses. Bye-bye purple, bye-bye pink pen. It's been great, but you're too dry. Your time has come. Poor pink pen. It was a great pen.
Will you just keep bringing this down?
This is important stuff, guys. Don't just count on your neighbor to do all the work, because she's not going to be able to help you on a quiz. What do you got number-wise? 14.2. 14 grams of O2. Okay, so what does this mean? This means if I take 16 grams of water and I hit it with high voltage, bzzz,
We're all gonna die.
no, then if I get 16 grams of water, hit with high voltage, I'm going to be able to collect 14 grams of oxygen and 2 grams of hydrogen. Just go subtract. Okay. Yeah, we used to do that until I got really, really impatient. There's this thing called the Hoffman apparatus where you have a column of water and 2 electrodes, and the electrodes, you turn them on and bubbles come up, bubble, bubble, bubble. You're like, oh, that's really great. When will I have enough to blow it up? In about an hour. So I didn't bother with that. But that's what happens. If you want to do it yourself, you can get a fish tank and a car battery and then run electrodes into the fish tank, and then hydrogen will come up at one electrode and oxygen will come up the other electrode.
You know, just the car battery I have laying around in my room.
Exactly.
The extra 5 car batteries.
And the fish tank too. You want to take the fish out. Yeah, you want to take the fish out. They're not going to enjoy the experience. Okay. Give me a thumbs up if you're comfortable with this. Okay, any questions? I'm seeing some thumbs side and 1 or 2 thumbs down. Yeah.
Okay, so I'm confused on how, like, when do you know which, like, to convert to what? Because the numbers isn't like the hard part, it's just I don't know when to use moles and grams.
Very common. Okay, so the first thing right away, guys, pay attention please. The first thing right away is whatever you have here is going to move down.
Yeah.
Whatever you have here is going to move down. Whatever you have here is going to move down. Next, you need to be able to change chemicals. And the only way you can change chemicals is converting your chemicals to moles. So if you don't have mole in your first chemical, convert that first chemical to mole. Then once you've got the mole, then you can do the mole ratio. And then once you've got your next chemical into mole, you can convert it back to gram. Okay, so that's the most important thing, is if you don't have mole, get your chemical into mole. Okay, if moles is given, that step is taken care of for you. Okay, and then once you've converted your chemical into mole, you can convert that second chemical into grams. Other questions? Let's do another one. All right. If you react 15 grams of hydrochloric acid, HCl, with excess zinc, as much zinc as we want, how many grams of zinc chloride will you produce? So, if you react 15 grams of hydrochloric acid with as much zinc as you want, how many grams of zinc chloride will you produce? So, I'll get you started on this one, then I'll be behind you in a couple of minutes. So we're going to get started with this one. And what is my starting unit? 15 grams, HCl, and my goal is grams of zinc chloride. So I got your formula right up there. If you could please work on this, I will be behind you in a couple of minutes, and we'll see how we go.
So I'm after this program. So oh, I think it's so I have oh yeah, so it's 2 grams. And you have how many grams so there's 70 plus 5.
Yeah, guys, remember, don't do any math until the entire T-chart is done. Don't do any kind of shortcut math. It's a really bad idea.
So 15 times 135, that's what
And so he has the day where he has to pay and then like
Yeah.
So I got to here.
Excellent.
But how do you get that? Like how we got 32 there? Where does that come from?
From the periodic table.
So that's just like zinc and chloride, their mass.
Exactly. Yep. So anytime you have a gram per mole or a mole per gram, the gram is going to come from the periodic table. 2 chlorines and 1 zinc.
Okay.
Ellie, do you have a question? Ellie, did you have a question? No? Okay.
I was gonna beat him up. I was like, if he told you that, like, you
Yes. It's probably on a different page. I would have circled the name if it was gone.
What's the difference between the mole, the 1 mole HCl and the 2 mole? What's the difference between them?
Okay, so this block is the gram per mole conversion, the molar mass. It allows us to turn gram of one thing to mole of the other thing, or mole of that thing to gram of this thing. The next block is the mole ratio, and the mole ratio allows us to change chemicals. And the mole ratio comes from the balanced chemical equation. So those numbers are going to be the coefficients in front of the equations. What did you get for grams of zinc chloride?
28.1.
Is that the answer or the grams of zinc chloride?
135.
135? And the final answer you got?
28.1.
28 grams of zinc chloride. Okay, so looks good. Is that a yay or is that a frustration?
Yay.
Okay, so let's walk through it again. What's going on, America?
Is it okay if it's a decimal?
Sure. Yeah. Okay. I just rounded down to 28. Okay, so don't panic. Let's walk through what we did. We had 15 grams of hydrochloric acid. Okay. We needed to get that hydrochloric acid into moles. So I converted my grams of hydrochloric acid into moles of hydrochloric acid. I used the molar mass to do that from the periodic table. Next, now that I have moles of HCl, I can now convert to the chemical I want. And I use the mole ratio to convert from moles HCl to moles of zinc chloride. The only way we can change chemicals is with the mole ratio. So once you get to moles, you say, yay, I have moles. My first thing, I can do a mole ratio to change chemicals. I'm halfway there. And we do. 2 to 1 becomes from the balanced chemical equation of 2 HCl to 1 zinc chloride. 2 HCl to 1 zinc chloride. Yeah, totally okay. Yeah, it's okay to have one reactant, one product, totally all right.
So you just look for that specific compound.
In the balanced chemical equation. Yep. And you write down the coefficient. The coefficient in front of that chemical. So we've changed chemicals. We've changed chemicals to zinc chloride, so we're halfway there. But the exercise doesn't want moles of zinc chloride, it wants grams. So we bring down the moles of zinc chloride and convert to grams using, once again, the molar mass off the periodic table. 1 zinc and 2 chlorines. 1 zinc at about 56, 2 chlorines at about 71 or 55, so you get the idea. 74, 6, 71, anyway. Okay. So give me a thumbs up if you're comfortable with this so far. Kind of my question for you is, do you want to do one more on the board, or do you want to do work on the practice worksheet? Practice worksheet. Okay. We will do the first one together, and then I'll let you use the rest of the time to work.